morning. I'd like to welcome everybody to the County Legislature Committee of the Whole this morning, and we'll start with the Pledge of Allegiance. If you'd stand with me, please. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. Roll call, please.
Mr. Barnes.
Present.
Mrs. Burdick. Here. Mr. Curran.
Here.
Mr. Sear.
Here.
Mr. Demick.
Here.
Mr. Fanton. Here. Mrs. Hanchett. Here. Mr. Harris. Mr. Havey.
Here.
Mr. Healy.
Here.
Mr. Rickey. Here. Mrs. Ricketts Swales. Here. Mrs. Root. Here. Mr. Rumfelt.
Here.
And Mr. Stockin.
Here.
14 present, 1 absent.
Thank you. The first item on our agenda this morning is to be updated on the new Public Works building in Friendship. So I'd like to turn the floor over to Tom Windus, our chairman of PTW, so superintendent. Thank you, sir.
Okay, thank you very much. Really what we're here just to talk about is the geothermal report that I handed out last week. We have Greg Barr and Mike Seglebing from Hunt to answer any questions, go over what we believe should be the next steps. And, you know, that's really the premise of what we just want to accomplish today. So we get better directioning and make sure everybody's aware of where we're at. As we handed out last week, Tatum was a sub to Hunt, and they've done many of these reports, and you know, in a nutshell, it looks like it's a little more promising than what we initially had thought to do a geothermal. However, you know, you had the proposals from before. This was the first proposal was for a few $1,000s to go this far. So it gives us an idea of possible costs. What we're recommending from here is if it's the will of the board to move forward with us in this direction, possibly take a baby step farther and do a sample well, and then do schematic design to then have a better idea of exactly what it would cost in differences. Because, you know, as Greg has mentioned to us, until you have that sample well, you don't know exactly how much energy you can put in and take out of the ground in that location. So as far as the report, let me turn it over to Greg. I'm sure he has some better understanding of it than I will ever have, and can answer any questions if you may have some.
Greg Barr, just Vice President Hunt Engineers. I've been a Hunt Engineers for 25 years, 28 years mechanical design. You know, there's a couple things that initially when I looked at the report, the two things that we compared in the report, or were compared in the report, is an estimate on a full design, which was the baseline estimate, and then an estimate projection for a geothermal system. So we have actual estimate based on a set of drawings versus a theoretical estimate based on what somebody believes a geothermal system would cost to install. Tom mentioned the schematic design. That process would really be taking and converting the mechanical equipment over to geothermal platform, projecting the number of wells that we believe we would need, and then take that schematic design and take it to our CM and basically get a good estimate. And then, but what I mean by a good estimate is they will actually get current cost for equipment. So just for everybody in the room, equipment cost is up 30% at the least, and we have some products that are up 50%. So the estimate for the geothermal system was based on RS means, which is an average cost, unity cost kind of product. And I'm not suggesting that that cost is inaccurate. I'm not suggesting that that cost is understated. I'm saying I'm not confident that we can move forward. I can move forward telling you that that's a good direction to go. As far as geothermal is, I've worked with probably 15 geothermal systems, some designed really well and some designed very poorly. And it's the very poor designed ones that cost people a lot of money moving forward. And I would definitely want to sit down, if we decide to go that direction, sit down with the energy consultant that we worked with and talk about the good practices that are in the design. And then the second piece would be making sure that all the effort that was put into the design to make sure that the spaces would be comfortable are replicated in the new design that involves geothermal equipment. And I wouldn't want to take a step back in terms of comfort of the space or quality of the air system in the space to go to a geothermal platform. That's why I would suggest a schematic design. Well, schematic design would basically give us today's number based on what we think. We could also put in a unit price for, let's say, additional wells. So geothermal wells, depending on where you are, if you're drilling a 400-foot well and you're 50 foot down and you hit bedrock and you want to go 450 feet, drilling through 400 feet of bedrock, costs a lot of money. If you're drilling a well and you have 100 foot of loose material that isn't bedrock, you have to encase that upper half of the well to be able to grout the tube in place. You're shaking your head no. What's that?
Most geothermal drillers use mud and don't put casing in.
So are they, how do they drill all the
And
way
then
to
they
the
grout the whole thing.
bottom?
All the way down, you use mud.
And they're taking the tube down with it, with the drill?
They're not putting any casing in. Then they pull back and grout it.
Right, so we've had situations where that's called collapse, right? So you drill a hole and you basically pull the drill bit out and the hole collapses on itself.
If you don't know what you're doing with
That, well, so
Yeah.
I will remind you, I know your husband does geothermal. It's a public bid environment. I'm not sure I'm gonna get the highest quality individual. So there are some things that are put in there for protections for that. But the cost of a well is a big number, right? It's a large enough number that if you have to double the number of wells because of the poor performing ground condition, or you are drilling a shallower well for a specific reason versus a 450-foot well, the more times you set up a rig, the more times you drill a hole, there's costs associated with that. So we would certainly want to have that in an estimate so we could have the conversations about, is this 12 wells? Is this 16 wells? Is this 20 wells? Is this 24 wells? Because I think if I look at the building as a whole, the cost to put mechanical equipment in the building to treat the building is the same, whether it's mechanical systems that are conventional or geothermal systems. Geothermal equipment costs a little more money up front, but I have less equipment like boilers and hot water heaters and that kind of equipment, and less piping that's needed in the building. So there's sort of this trade-off. The added cost really is the drilling of the wells and connecting of the wells to the building. So my belief is, with the incentives, with the push from the state, with the desire that the state wants to see buildings electrified, we want to see this step and basically say, is this savings really what the county should see? And I think that should really be done with a schematic design and a test well. So I think that's the piece that I would want to start out with for you guys. And I'll take any questions you guys have.
Thank you, Phil. Yes, what would be the life expectancy of the geothermal system?
So the actual well field, 50-plus years, right? You're talking about inert materials, HDPE plastic pipe in the ground, that material doesn't rot. The ways that you connect that material doesn't rot. Inside the building, though, however, everything is compressor-based. And we know compressors running every day or at least part of a day. The start-stop cycle of a compressor is what ends up wearing the equipment down. Those kind of piece of equipment, we say 20 to 25 years. There's a building I'm working on right now where they're 19 years, and they're starting a process of 6 failed this year, 4 failed the year before, and they're a heat pump.
Right. And that's, you said that building's been using this type of,
Yeah,
for
so
19 years?
yeah, so that,
Because that's relatively new, like, going
Yeah.
back, that's probably about the time.
yeah, a heat pump is a heat pump.
Yeah.
Whether it uses water that comes from the ground or ground loop, or it uses water that's supplied with a boiler and a cooling tower. It's still a heat pump. The only difference is in a geothermal system, they put protection within the heat pump, because in the wintertime where you're pulling so much heat out of the ground and your temperatures going back into the ground are so low that the temperature coming into the heat pump is relatively low, and you have problems with refrigerants collapsing. So they have to put protection in a ground source heat pump system to prevent that refrigerant from collapsing. So the only difference between standard heat pump and a geothermal heat pump is that particular part of it.
Another question. Any additional requirements that would be imposed upon us by higher authorities at state or federal level due to the fact that we're a government agency? I mean, it always seems like we got additional costs with any project we do. I know a lot of the people working on the solar and windmill projects tell me that of course they're private, but they tell me that they push because it's green. They push a lot of their requirements out there, environmental, for the construction phase right out the window. So I didn't know if there is for us or isn't for
Yeah,
us.
so the rebate that they identified is the clean and green rebate, and the incentives that are there, in addition to meeting what is considered the minimum efficiencies for equipment. So system energy efficiency ratio or coefficient of performance of the heat pump, they actually make you exceed those values by a certain amount and make sure the building envelope exceeds standard values by a certain amount. And in talking to Mike about the building envelope, we're already a little bit above and beyond what is baseline requirements, because the code makes you take additional steps, right? You need to do this, and then they say you need to do one of these other things. And one of those other things might be your wall insulation through your whole facility needs to be increased a certain percentage, or in the electric world, that your lighting has to become that much more efficient. With LEDs, that's pretty hard to do. So there's all of these different things that are different energy code triggers that make you go back to look at that. So that's another thing we have to look at, is there might be some incremental change to the building envelope system to get the grants that are associated with the study.
Thank you.
You're welcome.
Other questions? John?
You mentioned big number. What's a big number?
Well, I mean, I would say years ago, I would say if I were looking at a geothermal well, I would say you wouldn't predict anything less than $25,000 per well, or $15,000 per well. With what's going on with our industry right now, and with the cost of materials, the cost of tubing, I would look at that and say that could be $25,000 a well. So if you need 4 more wells, it could be an additional $100,000. So getting the right number of wells, getting the test well so we know exactly what the ground can take, we can, figure out exactly what we need to have in the final design. Again, if we need 8 more wells, it's an additional $200,000, the way I project it. And, a well driller might look at that and say, oh, well, we can get away with a well that's this price, but we don't know that till we drill the very first well and know what the conditions are associated with that very first well.
And after you drill the first well, say you hit perfect soil, perfect whatever, how do you know that 50 feet down the road? Do you
Yeah,
know?
so,
Does
I mean,
that tell? I'm not a geologist.
There's geographical survey type materials that'll say, it shows pretty good land use materials, which show you surface covers, it'll show you depth of bedrock, and these are generally in very large areas, right? So I can tell you the last one I did where we started the design, halfway through our geothermal test well, we pulled up a black oil sheen on top of the water, and the well driller basically said, we're done. So that was down in the southern tier. We basically hit a pocket of oil halfway down through drilling the test well, and he basically said, we're done. Owego Appalachian School, they blew up a well. They blew up $1 million, rig. Basically hit a pocket of gas and ignited it. So, and I'm not trying to scare anybody with that, but there are those instances where you stop, right? Where you say, am I good with drilling this many wells when I found evidence of oil? Because I'm drilling, in the drilling process, I'm drilling through the surface, I'm drilling through the subsurface, I'm drilling through confining layer number 1, confining layer number 2, and I'm drilling down through aquifers as I drill down through those depths.
Okay. Just last question.
Yep.
So I don't see there a whole lot of it around here, at least I don't know about. Who fixes this if there's a problem? Can you find people around, or do we have to send the state of Washington to bring in a specialist, or can you find someone in Rochester?
A properly constructed well field doesn't need fixes. We have well fields under football fields, turf football fields. These are $1 million stadium investments, and there's rows and rows of geothermal wells underneath that stadium turf. It's a process of building it correctly the right time through. Lots of times, if you have a problem in a big system, you have a problem with a certain area of it, you dig up the location, you basically bypass that well. You don't go back and try to repair that well. You go back and bypass it. It's the equipment-wise, the equipment is standard equipment. It comes from Aon, Carrier, Train, major manufacturers. This is not something that is unique, that comes from, overseas. This is pretty standard equipment.
Okay, thank you.
You're welcome.
I'm just gonna
Deb?
go back to some of the wells. I think it is very important to do your cost-benefit analysis and to how many wells you need. Sometimes you have to look at whether or not you need 10 400-feet wells, or is it cheaper, more economical to do 5 1,000-feet wells. So you have to look at that when you're deciding all of that. Most of your geothermal wells are not your water wells. They're a borehole that you go in and you put grout in. And most people charge by the foot. So if they come in and you drill a water well, you're going through all kinds of consolidated bedrock. In Belmont, you go through mud. You learn how to drill through all that. Most of your oil wells in Allegheny County are about 1,000 feet. Most of your water wells in Allegheny County are about 200 feet as an average. Just so that is around this area with the consolidated rock formations and all that.
I got a question, Phil.
Mike?
Do we know what they are right in that particular area, how deep the wells are there on average?
I don't, in terms of, we could talk to Moody, and we could talk to other people that drill regular wells. There's a company that we,
New York State you could go to New York State because they have all the well logs for every well that's drilled in New York State.
The DEC.
DEC.
Yes.
You could talk to a local well driller, they'll tell you but you're not after water.
No.
Right.
You're not after water. So what you're after is the efficiency of the heat coefficient.
Right.
Of how much heat you're going to get out of the ground. So the water is
Irrelevant.
But the well
not.
logs thank you. The well logs will tell you what the composite of the soil is all the way down to whatever you want to go down to. And that will give you your heat coefficients.
Right, that's why I was wondering, okay.
it would be fantastic if 30 feet down we hit bedrock, because bedrock is probably the best, right? It's
Yeah.
that dense material that helps the heat dissipate into the ground. It's the other stuff.
Yeah.
Dealt with it, a school district down at Bellefonte that didn't drill a test well. In the process of drilling all the wells, they hit a whole bunch of natural underground springs and limestone formations, and basically their whole well system would not perform during construction because nobody did a test well. So those are the kind of things that when we look at this and said, okay, what we expect, what we think the well should do, the test well will give us exactly the information we need to determine how many wells are in the job. But for a schematic estimate, we can estimate the number of wells, we can estimate the depth that you want to go. Most systems I've ever worked on and designed have been 400 feet max. It just seems to be the standard. So that's probably what we would base a well on. But we have to take a guess at, say, how many feet per ton that we have to expect that ground to take. And there's some standards for vertical wells versus horizontal pipe distribution. So again, as Tom mentioned, with the incentives, with the push from the state, and, you know, with the ability to simplify the payback from 17 years to 5 years with the incentives, it seems like something that you know, if you want us to look at that, I would suggest that we either do a schematic design, get a real idea of what the cost of the system is, and if we have an add-on for additional wells, and that looks like it's an acceptable piece, then I would suggest you drill a test well, and you validate exactly how many wells you need to build.
Yeah, what's the cost of drilling a 400-foot well? Have you got a number that's close?
If you talk to anybody and you look at what they say for drilling a well can be anywhere from $12 to 65 cents, $65 a foot. So if you looked at that, it's a $15,000 well to go 450 feet at the high cost. At the low cost, we want bedrock. Bedrock is probably one of the hardest to drill through, right? So I would expect that would be higher in the cost range. That's why I believe by the time you drill the well, you get the tube in the ground, you get all the tube connected and get it to the building, you probably are looking at $20 to $25 or $25,000 a well.
Yeah, it seemed like there might be a question. I know Deb mentioned clay, filling it full of clay. I assume that's,
Yes.
once you drill the hole, you were talking about casing. So which would you recommend? I mean,
Well, again, when you drill down through a terrible material that doesn't want to hold its shape, and you pull the drill set out,
Yeah.
if there's no way to get the tube into the ground, your bedrock hole is worthless. So again, that all depends on what the condition is down there, and I need, do a little more investigation into that.
Yeah.
There's rules and regulations. New York State has regulations on how you drill these wells. They have regulations on the grout and all that. Any person who's going to drill the well has to abide by those rules and regulations. There's a lot of regulations when it comes to this, and they have to meet all of that. Yeah, you pull your casing out. You don't really want to leave the casing in the ground, so you put grout in. So it's all based on your grout.
Right.
And there's many different types of grouts. There's many different types of grouts that have better heat coefficient than other grouts. And so it's there's not one size fits all.
That's true.
well, if you're drilling through basically the water level, somehow you've got to seal that section off, whether it's grout or whether it's tubing. So,
Yeah, I mean, the grout really is both a thermal
Yeah. Conductor.
transmitter as well as making sure that we don't have, transmitted groundwater from one aquifer to the next. Because as you look at that, people are drilling 250-foot wells for water because they don't want the first layer of water that is under the
Right.
gravel and dirt layer, because that's full of surface contaminants and that. And when you drill a well further down, you basically have bedrock filtered water at that point. So you've gone through that layer to make sure your water's protected.
So it sounds to me like we really need to put a test well in to find out what we're doing. So that'd be, I think, our next decision.
Yeah, and there's several well drillers that we've dealt with, and if you want to give me your information, I can even speak to your husband. And, just to get that understanding of, what's that?
But I'm not here promoting this.
No, and that's not what, I like different opinions. People give you different opinions depending on who they are. So, that's a big thing for me is first of all, understanding that part of it. And we may find somebody that says, oh yeah, I did one of those, pretty nearby, or this is what we found and this was the cost of that. But to rely on a building design to use a well to reject energy to the ground, yes, you have to do a test well.
Mike?
I want you to know that I'm wholeheartedly behind a new shop project, and if this makes sense, geothermal, I'm all for that too. My biggest question is the location of the current shop, and I certainly don't want to see the shop moved out of Friendship because I represent the town of Friendship, and but the site to me leaves a lot overall to be desired. And if we're investing this type of money, I don't know if that's the best option to stay at our current location or not. And I just want to make sure we're spending all our money or investing our money as well as we can. Thank you.
Yeah, and I don't think Greg has much background in that respect. And maybe, Mike, that's a discussion we should have before we even authorize the next steps. But, you know, my suggestion would be, as Dwight said, maybe if we're in agreements, next Public Works Committee will bring forward a proposal to do the schematic design and a test well to where then we have more information going forward.
Thank
I
you.
can agree to that, Tom, before we get too far in the weeds with 100 different questions. I agree, let's punch a hole and go from there.
So at least we'd have a proposal.
Move this forward.
We'll have Hunt prepare the proposal for the schematic design. They'll get 3 different quotes from drillers, and, you know, they'll hire them, do that work for us, and then that way we'll have a report that comes back, if that makes sense to everybody.
Other questions?
Thank you
Anything
very
else,
much.
Tom?
No, that's it. Thank you.
Thank you.
Thank you.
Thanks.
Executive session. The matter related to a particular person or corporation, I can do a couple updates. You wanna just, Sheriff won't be here.
Same.
Same one, but we can just kill somebody before the sheriff gets here in a couple of minutes.
Okay, at this time, I would like a motion to go into executive session for the medical, financial, credit, or employment history of a particular person or corporation, for matters leading to the appointment, employment, promotion, demotion, discipline, suspension, dismissal, or removal of a particular person, corporation.
Mr. Chairman, Legislator Rumfeld will make that motion.
Motion by Rumfeld,
Hanchett,
support by
second.
Hanchett. Any discussion? If not, all in favor? Opposed? And we're in executive session. I'll let Carissa.